formula. Empirical formula is simply the simplest ratio of numbers. Okay? So let's take something simple. What's the formula for glucose? C6H12O6. Now when we say that we want the simplest ratio of numbers, what would the common denominator be for the subscripts in glucose? 6. If we're looking for the ratio, the simplest ratio of these, what would it be?
1:2.
So 1, 2, 1. So that translates into a formula. What would be the formula for this ratio? C H2O. This is what your empirical formula is. Okay? Now, here you have your empirical formula. And here you have your molecular formula. Okay? Your molecular formula has all of the atoms present in your compound. Your empirical formula has a ratio of atoms present in your formula. So let's say if you had H2O, what would be the simplest ratio for H2O? The same thing. So this tells you that your formula can be both your molecular and your empirical formula. Some compounds have the same molecular formula as the empirical formula. Right? So we are going to be able to be able to calculate our empirical formula given certain bits of information. Things that you need to know in order to calculate your empirical formula. You must know the elements that are being combined. You must know those. You must know their atomic masses. You must know the actual masses of the elements if you are represented by their percentages. So if I tell you, for example, oxygen has 50%, water has 50% oxygen and 50% hydrogens. You would have to know that each of them contributes this much to the molar mass. Alright? So here again, step 1. If I give you the masses in grams, you are going to use grams to carry on for the rest of the remainder of calculating the formulas. However, if I give you percentages, so if I give you oxygen equals 68.3%, you must convert this percentage to grams. How do we do that?
Divide by 100.
Huh?
Divide by 100?
No. What you're going to do, you're going to take your eraser, erase the percentage, and write grams. That's it. That's how you do your conversion. Okay? The reason why we can do that is because we're assuming everything is at 100%. 100% can translate into 100 grams. Alright? Step 2. Convert your grams to moles.
So then you do a conversion factor.
Then you do your conversion factor with your molar mass. Each element that you have them listed out. Then you have the masses listed out. You convert those masses to moles. The masses will be given to you in convert that to moles. Then you would identify who has the lowest moles.
Which element?
Which element has the lowest moles? Once you find that, then you're going to divide everybody by the lowest moles, and that gives you your ratio. Now, if you get your whole number, you're good. You stop at that point. You stop after step 3. If you do not get a whole number, you must multiply something. You must multiply, for example, if you get...
Is this from converting grams to moles you're speaking about?
No, I'm talking about after you divide it to get the ratio.
So when you convert from grams to moles, if you get a decimal, that's okay?
You're fine. So once you have your ratio, if you get 0.25, you cannot round this. You must multiply this. If you get 0.25, 1 and 1. You must multiply this number by an integer to get a whole number. What do you multiply by this to get a whole number?
4.
You multiply this by 4. If you multiply 1 by 4, you must multiply everybody by 4. So that gives you 1, 4, and 4. Now, if you multiply by said integer, and you get something like 0.99.
Let's go to 1. So it's close.
This is equal to 1. The only time you can round is if you are 0.1 away from a whole number. Now, keep this clear. Every other time, when do we round?
5.
If you have 5 or above. When you're working with empirical formulas, you can only round if you are 0.1 away from a whole number. That's if you are 2.9, you can round that to 3. If you are 2.1, you can round that to 2. All right?
So
Yes.
what would you do if you had something like 0.98? What would you?
Is that not 0.1 away from a whole number?
0.99.
No. That you're jumping. You're jumping the gun. Okay? So you tell me 0.98.
Yeah, I see what
You see it? 0.1 is at this here.
Yeah.
So this is 0.1 away from 1. So you can round that up to 1. So,
But if it's going to be like 0.88, then no.
Then no. 0.88, no. You must multiply by an integer first.
A whole.
Okay, so here's a couple for you. You have 0.33. You can multiply that by 3 to get your whole number. We did 0.25. You have 1.33. You can multiply that by 3 to get your whole number. 1.8. Multiply that by 5 to get your whole number. Alright, so you have to go through the steps in order to figure out what you need to multiply by to get your whole number, or 0.1 away from your whole number. Do we get it?
That
Correct.
concept, I don't understand what we're doing on the whole.
We're trying to find the empirical formula.
Okay.
Alright, let's take an example.
Yeah.
Alright? And we're going to do it together. The compound para-aminobenzoic acid is composed of carbon 61.31%, hydrogen 5.14%, nitrogen 10.21%, and oxygen 23.33%. Find the empirical formula. What does step 1 tell us to do? Write everybody out. So you have carbon. What's the percentage for carbon?
61.31.
So it's 1.3, 1%. What's the next one?
Say
Hydrogen,
5.14
-2.
percent.
Next one,
Nitrogen,
what is it?
10.21.
3.1
1%.
to 1%. Next one,
23.33%.
step 2.
Scratch out all the percentile.
Scratch out all the percent sign and put what?
Grams.
Grams. Step 3.
Convert grams to moles.
Convert grams to moles.
Would the conversion factor for that be, like, for carbon per se, 61.31 with 1 mole
1 mole where?
at the top, and then 12.01 at the bottom,
-2.
the grams? Let's do
I'm the same one we asked.
5.105 moles of carbon.
Tell me again?
5.105 moles of carbon.
For hydrogen?
It's 105. 5.105.
hydrogen would be 5.14 moles.
5.10. 1 mole divided by 1.01 gram.
1 gram is fine.
It's 5.18, yeah. Let's see what she changed it for 25.
For nitrogen, what do we have?
1 mole divided by 14.01%.
How much?
0.73.
0.7.
3 moles.
72.
Okay.
7288 moles.
7288 moles. Over here.
1 mole over 16 grams.
.8973.
-2.
Moles.
Step 3. Or step 4. What do we do next? Divided by? No. We now need to find our ratio.
For oxygen, I got 1.45.
So Ronnie's saying he lying to me? That's what he was telling me?
What was my calculator like?
So what do you have? 1 point?
45.
4, 5,
8.
8. Right? What's next? Divide by the lowest mole. Who's my lowest moles?
7.298.
Okay. So we divide everything by that last one. right there?
Everything by the lowest mole, not the last one, but the lowest mole.
Yeah, okay.
I mean, 5.44.
So now what happens to the units here? They cancel out because you're dividing moles by moles. So now what do we have for carbon?
Seven.
Hydrogen.
.0521.
Now what do we do?
Okay, round the other one off.
Can you round it?
Yes.
How can you round it? What's it gonna be?
7.
7. So now, you have your ratio. What you're going to do now is put your empirical formula together. So you have 7, 7, 1, and 2. What's my empirical formula?
C7.
C7,
H7.
H7, and O2.
Professor, you divide by the lowest or multiply by the lowest?
Divide by the lowest number. So here, first thing we do, we convert our percentages to grams. We did that. You converted it to moles. We did that. We got this, roughly the same values. Then you divided by the lowest moles. You got the ratio. Everybody is 0.1 away from a whole number.
So, Professor, do
Yes.
we have to round only the, like, 6.9? We don't have to...
You don't have to worry about any, no, you don't have to worry about anything that's more 0.1 away. And you just put it together. Do we get it? Okay, let's try one then. Oop, no. Okay, before we do that, before we try one, you can go from your empirical formula to your molecular formula. What all you need to know is the molar mass of your molecular formula that I will give to you. Okay? So here is the formula. You have to ultimately find a magic number called N. N, how you find N? You have the molar mass that I would give to you. I'm just saying, I will give that to you. Divided by the empirical mass. The empirical mass you have to calculate. How would you calculate the empirical mass? What do you mean what you just did? No, you just calculated the formula.
Okay.
Now you need to find the mass. How would you calculate the empirical mass?
Using that thing.
Using that thing, and then do
Oh,
what?
then times and by what's on the thingamajig, the
That's
by the
the
table.
number.
There you
Oh,
go.
okay.
Okay? So same way you calculate the molecular weight or the formula weight, the same way you
So then
calculate
you do 7 times whatever number.
7 times 12, 7 times 1, 1 times 14, 2 times 16, and then you add everybody up.
So what's that conversion that you have right there?
This?
Yeah,
This is your magic number.
that's for N
That is N. N is your magic number.
to find the empirical weight.
To know,
The molar
to
formula.
go from your empirical formula to your molecular formula.
So
You need your magic number N. How you calculate your magic number N? You will be given the molar mass divided by the mass of your empirical formula, which you can calculate.
okay, so like, say for like H2O, right? H2O and the molar mass is 16.
Oh, try it again.
18,
Uh-huh.
right? And the empirical mass of H2O is also 18.
Right.
18 divided by 18 is 1. And
Right.
I multiply that by the subscripts of my empirical formula to get the same thing. So
Yes.
H2O is H2O.
Yes.
But how
Well, wait. Huh?
what's the molar mass again?
What did I just tell you about the molar mass? That you sit there and you laughed at me?
Oh, you won't give it to me. Oh, okay, my bad.
Uh-huh. All right. Once you find your magic number, you are then going to take that number and you're going to multiply it by all of the subscripts in your empirical formula.
Once you find that N,
Oop. Once you find that N, you're going to take that N and multiply that N by the subscripts of your empirical formula.
But what if you don't get a whole number? Just
You will get a whole number. This is where you can round also.
so you round it by 5 or more, not
No, you will never have a 5 or more. it will always be like 0.108.
So.
It's always that precise.
Because of empirical formula
Yes,
exclusive.
yes.
Where we multiply n, then multiply by the,
Take your n, and you're gonna multiply n by your subscripts in your empirical formula.
so the 7, the
Yes.
2.
So we're almost out of time. So let's just do, again, this is what you need to do in order to calculate your molecular formula from your empirical formula. First thing you need to do is calculate your empirical formula. That's all what we just did here. Then you will calculate your empirical mass. Same way how you calculate your molecular mass or your formula mass. That's what you do. Then you divide your molar mass by your empirical mass to get your magic number. Once you do that, you multiply your magic number by the subscripts of your empirical formula. Let's take one, I'm taking like 2-3 minutes out of your break. And let's just do this one. I did half of your job for you. What is the molecular formula of a compound which has an empirical formula of CH2 and a molar mass of 126.2 grams per mole? I did half your job already. What do you need to do? Find the empirical mass. What is the empirical mass?
162.4,
126.2 grams per mole.
So the empirical mass is
14.
The empirical mass is
14.
minus 2
14
grams per mole.
Oh yeah, because it's 12 plus the 2, no?
Right.
9.
Oh, we times it or we plus it?
What plus?
So 1 times that. Oh, so we plus it. Okay, we plus it. We add it.
Step 3. What do you do at this point?
Divide those 2, no?
Divide your molar mass by your empirical mass. You get n is equal to 9.
So C9 is 18.
And then 9 times 1, 9 times 2.
Very good. And what do you get?
C9H18.
C988.
Oh, so you write it out like that. Okay, okay.
Yes.
Mm.
All right. I didn't use up any of your time. Messed up now. Yes.